This lesson is on functions, and we're going to talk about how to tell whether or not something is a function in some different settings. The first is with a graph. And if you are looking at a graph, you want to do the vertical line test, which sometimes I abbreviate VLT. And that means I just pass a vertical line across that graph, and if it hits it more than once at a time, then it is not a function. But this one's okay because each vertical line that I draw, I can only pass that function at one point. So this is a function. And then over here, this is a classic example of not passing the vertical line test, because I could draw a vertical line test like right here or right here, and both of those vertical lines would be hitting in 2 points. And so more than 1 point means it's not a function. So yes, this one is a function. No, this one is not a function. Okay. Also, we want to be able to look at a table or a set of points and tell if it's a function, and what we're looking for there is to have no repeated x values. So it is a function if there are no repeated x values. So if you're looking at a table, all I'm going to be focusing on are these numbers here, our x values, and I want all of them to be different. It doesn't matter what the y's are, just if the x's are different. And so since all the x's here are different, yes, this is a function. Okay, in this set of points, again, I don't care what the y values are, just look at the x's. I have 1, 3, 1, 6. So because this 1 and this 1 repeat, then this is not a function. Okay, the next thing we're going to look at is a mapping, which you may or may not have seen before. And a mapping it shows a domain and a range, and it has arrows drawn from one to the other. And I probably should label this one D and R for domain and range. But if we look at these, we want no domain value to have more than one line coming from it. Okay, so a function would have only one line coming from each domain value. So again, I'm not looking at the range, I'm just looking at the domain. And I want each one to have one line. So 1 has one line, 2 has one line, 3 has one line, 4 has one line. Yes, this would be a function. In this circular type of mapping look, again, I don't care about the range. I don't care that there's 2 pointing to 6 or 2 pointing to 7. I only focus on the domain. Since there are 2 lines coming from the 1, it's already not a function, but there are 2 lines coming from the 4 as well, so that would make it not a function. So there's several reasons that this is not a function. So no, this is not a function. Okay, the next thing we're going to talk about is algebraically what they want you to do with functions. And one of the things that they want you to do is to evaluate a function. And anytime they say evaluate, that means plug in. So anytime, even when you're doing things different than this, if it says evaluate, you want to plug in, you want to get a numeric answer. And so the nice thing about function notation, when you have f of something, whatever they put in that parentheses is what you plug in. That is why we use function notation in upper maths, because one, the f tells me it's a function, or the g or h, whatever they're naming it, tells me it's a function. It passes the vertical line test. But what's in parentheses tells me what we're plugging in. Now, there will be other times when we're doing things. This does not mean multiplication. This f parentheses is not multiplication. It is literally saying plug in. It's more like a substitution thing. So our first example over here is this g of x, and I have this quadratic equation, and they are asking us in number 1 to plug in 2. So I'm going to say negative 2 squared plus 4 times 2 plus 1. and then you just figure out what that outcome is. So I have negative 4 plus 8 plus 1, and that's 5. So my answer for that is 5. Okay, in example 2, we have a t inside there. So sometimes they're going to give you things that are not numbers, and in this case, I'm just going to plug in t. So everywhere I have an x, I'm going to put a t. So this is going to become negative t squared plus 4 times t plus 1. And in this case, since I had a variable in there, this is actually my answer. Okay, and you don't have to do anything else to it. It is that simple. Okay, for the third one, you have g of x plus 2. Now, this one is one that people sometimes mess up, but you're going to plug the x plus 2 in for both of these x's. These x's you need to take out. They're going to be replaced. They are no longer there. What I like to do is write that g formula and put parentheses where I had the x's. So it would look like this. So I have taken those x's out and I don't get too many x's in what I'm doing. After that, I go back in and fill the x plus 2 into those parentheses. So x plus 2, x plus 2. Now we're going to work on this one and simplify it. You have to remember your order of operations. Exponents come before multiplication. So I'm going to have to write this twice so that I can FOIL it out. I can go ahead and distribute over here and get 4x plus 8 and bring down my plus 1. But I'm still not ready to take this negative through. I need to multiply these out and get x squared plus 2x plus 2x plus 4. Then bring the 4x down. I can actually add the 8 and the 1 if I want to and say plus 9. Now I can take my negative through and have negative x squared minus 2x minus 2x minus 4. Bring down the 4x plus 9. And now I should be able to combine everything. So I have a negative x squared, a negative 2x, a negative 2x, and a positive 4x. So that would actually go away because I would have negative 4 and positive 4. And then I have a negative 4 and a positive 9, so plus 5. And so this would be my final answer. For my next example, I have what's called a piecewise function, and we're going to study those a little more. But for right now, what I want you to know is that you're going to plug into x squared plus 1 if what you're plugging in is less than 0. And you're going to plug in to the x minus 1 if what you're plugging in is greater than 0. So you only plug into one of those, not both. It's just which one applies to what you're plugging in. So for number 4, f of negative 1. You first look at the negative 1. That's less than 0. So that means I'm going to be plugging it into x squared plus 1. So I'm going to say negative 1 squared plus 1, which will be 1 plus 1, and that's 2. Number 5, I'm plugging in 0. So where does 0 fall? The bottom one is x greater than or equal to 0. So that is the one that I'm looking at. I have to plug it into x minus 1. So I plug in 0 minus 1, and I get negative 1. And then finally 5. 5 is greater than 0. Again, that's the bottom, so I'm only plugging into the bottom equation. 5 minus 1, and I get 4. Okay, the last thing that we're going to talk about is called the difference quotient, and this is part of a calculus formula. You learn how to work with it in this class and then how to use it if you take calculus. But it's basically what we're doing, just kind of combined into this formula. This first part, f of x plus h, means I'm just plugging in x plus h. Then I'm going to subtract whatever my function is, and it's going to go over an h, and I'm going to be able to simplify. When you do these things, a lot is going to cancel out. So let's start with that first one. I usually make a big fraction so that I can plug everything in that I need to. And I'm going to start by plugging in the x plus h. So look at your equation, plug in x plus h for both x's. If you have to, put your parentheses. write out that thing, and then fill the parentheses in. So x plus h, x plus h. Don't forget the plus 7, it was part of that. Then there's a subtraction in the formula, so I'm going to bring a subtraction down. You're subtracting f of x, that's the whole function. You need to put that in parentheses or you will get the signs wrong. So subtract your whole function, and then it's always over h. Okay, now I'm going to start to simplify, and this may take some room. So the x plus h squared means that I have x plus h times x plus h. I can distribute the 4 through, but I got to take the negative with it, so negative 4x and negative 4h. Bring down my plus 7, and I can distribute the negative through this last parentheses, so negative x squared plus 4x minus 7, and again it's over h, so I need to make sure I put that denominator down. Okay, before I even go to multiply these out, if you'll notice, things are already starting to cancel. I have a positive 7 and a negative 7 that will cancel. I have a negative 4x and a positive 4x that will cancel. I can go ahead and do that so that I don't have so much to write if I want to. Now I'm going to come back and FOIL. X times x is x squared, x times h times x, which I can write xh as well, and h times h is h squared. Then I'm going to bring down what I have left, the negative 4h and the negative x squared. Again, it's over h. Now I can cancel the x squared and the negative x squared. Okay. And I can combine some things. So I have xh and xh, so that'll be 2xh. I still have plus h squared and minus 4h. Everything is over h. Because every piece has an h in it, you can think of it like factoring an h out of the top. And like it's a GCF, and then canceling. And you're left with 2x plus h minus 4. Okay, for the last example, example 8, we have another function, and you can practice the original difference quotient, but I'm going to have us practice one that's a little bit different because your book will ask you to do things that are slightly different than the original difference quotient sometimes. But again, if you realize you're just plugging in, look for what you're plugging in. Here I'm plugging in 4 plus h. So I'm going to put parentheses squared minus 2 parentheses plus 9. And I'm going to plug in 4 plus h. Then I'm subtracting in my formula, so subtract f of 4. So it's the whole thing, but with 4 plugged in. So 4 squared minus 2 times 4 plus 9. And again, we're over h. Okay, and then now I can simplify. So 4 plus h squared means I must write it twice because I'm going to have to FOIL. I can distribute the negative 2 through and get negative 8 minus 2h. Bring down my plus 9. And then minus all that comes out to be 17. We're still over h. Again, I want to FOIL here, so 4 times 4 is 16. 4 times h is 4h. h times 4 is 4h. And h times h is h squared. I can combine the negative 8 and the 9 and the negative 17. I'm going to bring down the negative 2h and then combine those three numbers and get negative 16. And we are over h. So then I start looking what's going to cancel. The negative 16 and positive 16 will cancel. Okay, so I can combine these four h's and think of them as 8h, but I need to take an h out of the top. That'll leave me with 8 plus h minus 2 over h, and then my h's will cancel. And I can say that 8 minus 2 is 6. 6 plus h is my answer. That concludes this lesson.